Today we're going to continue our notes on forces, but before we complete page 9 of our note packet, I want to review a little bit about forces to get us back into the swing of things. All right, if I was to draw a force, let's see if you remember how to draw it. It would have been your large force here, your smaller force on a little bit of an angle to the side, and your resultant goes through the middle, and if you connect it with a dashed line, you have a parallelogram. So you have a large force. This would be your large force here. This would be your smaller force. And the diagonal is called a resultant. Guys, stop. Mommy's doing a video. Okay, so the forces actually formed a parallelogram. And what do we know about a parallelogram? Opposite sides are congruent. Okay? Opposite angles are congruent. The diagonal cuts the parallelogram into two congruent triangles, which also gives you alternate interior angles. Angle 1 and angle 2 add up to give us, let's call this angle 3. And angle 1 and angle 2 do not necessarily have to be equal in measure because the resultant is definitely not an angle bisector. All right, with that review, let's go to page 9, number 2. A resultant force of 143 pounds is needed to move a heavy box. Two applied forces act at angles 3540 and 4730 with the resultant. Find to the nearest pound the magnitude of the larger force. Okay, so let's draw that. We have our large force and our smaller force. Here's our resultant. Hence we have let's draw that a little bit better, a parallelogram. Okay, let's make that just a little bit nicer. There we go. Okay, so now we have our parallelogram. It said the resultant is 143, so I'm going to put it in. It gives me two angles that are actually formed by the two forces. Well, that means one is going to go here and the other one's going to go here. I just have to figure out which one goes where. All right, well, the one that I would put on the top end would be directly across from the larger side of the force, so that definitely has to be the 47-degree 30-minute angle. So then this one has to be 35 degrees, 40 minutes. All right, knowing that, then this angle here is 35 degrees, 40 minutes, and this angle here is 47 degrees, 30 minutes, because alternate interior angles are congruent. All right, with that being said, let's take a look at what I have here. According to the information I have, or that was given in the triangle, I have angle, side, angle. So angle, side, angle has two angles one side, which means I'm going to use law of sines to actually find my answer. They're asking me to find to the nearest pound the magnitude of the larger force. So that would be right here, let's call it x. Well, let's see what I have here. I do have side 143, but I don't have that angle. I'm looking for x, and I do have the angle across from x, which would be 4730. I need to find the angle across from 143 in order to use law of sines. So what am I going to do? You're right. Every triangle equals 180 degrees. So I'm going to go 180 minus 47 degrees, 30 minutes, plus 35 degrees, 40 minutes. Remember, your degree symbol and your minute symbol is under second APPS. Pause the video, take a minute, plug that in your calculator, and then come back and see what you got. Since I'm giving you degrees and minutes, your answer has to be in degrees and minutes. Well, hopefully you ended up with 96 degrees, 50 minutes. So now I have this angle here, which is 96 degrees, 50 minutes. So now I have enough information to do law of sines. Nothing is labeled, so I'm just going to use the basic formula. A is the sine of A, as B is the sine of B. Okay, I'm going to say 143 is the sine of 9650, as X is the sine of, let's see, the angle across from X is 4730. All right, pause the video, take a minute, cross multiply, and find the value of X to the nearest pound. All right, hopefully you ended up with X to be 106 pounds. If you didn't, you're going to want to check your cross multiplication, making sure that you're actually putting in the degree and minute symbol when you're plugging it into the calculator. All right, let's go on to number 3, our very last problem for today. Two applied forces produce a resultant force of 18.6 pounds. The smaller force is 15.8 pounds and the larger force is 24.3 pounds. Find the measure of the angle between the two forces to the nearest tenth of a degree. Okay, let's draw our forces. We have our large force and our smaller force and our resultant, which goes beyond both. Hence, we have a parallelogram. All right, it said that the resultant is 18.6. Let's put that in. The smaller force is 15.8. Remember, opposite sides are congruent because it is a parallelogram. The larger force is 24.3. They want me to find the angle formed by the two forces, which would be right here. Let's call it X. Well, I can't use a triangle to find X because X is part of both triangles, and both of those angles are not equal in measure. So how am I going to be able to find X? Well, let's think about this. They gave me side, side, side. So side, side, side means law of cosines. If I could find this angle here, which is we'll call it Y for now, I would know this angle here, which means I know two angles of a parallelogram. I could actually take those two angles, subtract them from 360, then divide by 2, and then that will give me angle X. So there's my game plan. Okay, with that being said, I'm going to set up for law of cosines. So I'm going to have a squared equals b squared plus c squared minus 2bc cosine of a. A is going to be 18.6, so 18.6 squared equals, let's say b to be 15.8 squared plus 24.3 squared minus 2 times 15.8 times 24.3 cosine of, let's call it y. All right, I can't put everything into the calculator at one time because I have something missing, so we're going to piece it out. Let's see here. 18.6 squared is 345.96. All right, 15.8 squared plus 24.3 squared will give me 840.13 minus 2 times 15.8 times 24.3, there should be a point there, will give me 767.88. 767.88 cosine of y. Okay, I'm going to subtract 840.13 on both sides and end up with negative 494.17 equals negative 767.88 cosine of y. I'm going to divide each side by a negative 767.88 and end up with a very long decimal. I'm going to take that long decimal and go second cosine, second answer, because I need an angle. And I'm going to need the angle to the nearest, it said tenth of a degree, so in this case I'm going to go to the 100th degree, so when I actually get my final answer I can round properly. And you're right, it's 49.94 degrees will be angle y. Okay, so we have angle y. Now, knowing angle Y, I can now find angle X. So I'm going to go 360 minus 49.94 plus 49.94, enter, divide by 2 because what's remaining is the value of the two other angles, and opposite angles are congruent on the parallelogram. So my answer will be, to the nearest tenth, you're right, 130.1 degrees. So angle X is going to be 130.1 degrees, and that's my answer. Okay, if you have any questions about what we did tonight on our video, bring them back to class tomorrow and we'll go over them. Have a good evening.